In this lesson, we will go through the steps involved in balancing redox reactions. As we know, redox reactions involve the transfer of electrons. Since electrons are being exchanged between species, this means redox reactions also involve the change of oxidation states of atoms. Let's take a look at the following reaction as an example. Here we have solid zinc reacting with an aqueous copper 2 ion to produce an aqueous zinc ion and solid copper. Let's assign oxidation states to all the species here to see where the electrons have been transferred. Zinc, in its elemental form, has an oxidation state of 0. A copper 2 ion has an oxidation state equal to its charge, so it will be +2. Similarly, the oxidation state for the zinc ion will also be +2 due to its charge. And lastly, the element copper has an oxidation state of 0. Now if we take a look at the change in zinc, we can see that it increased in oxidation state from 0 to +2, which means it had to lose 2 negatively charged electrons. This means zinc was oxidized. Copper, on the other hand, decreased in oxidation state from +2 to 0, meaning it had to gain 2 electrons. This tells us copper was reduced. Now this reaction can be split into 2 half reactions, one for the oxidation process and one for the reduction process. This is used to help determine the stoichiometry of redox reaction equations that aren't balanced. Even though our equation was balanced, we'll take a quick look. The half reaction for the oxidation process involved solid zinc transforming into an aqueous zinc ion. The reduction process involved a copper ion transforming into solid copper. We can now add in the electrons that have been transferred to balance the charges of each half reaction. In the oxidation process, the left side of the equation has an overall charge of 0, while the right side of the equation has an overall charge of +2. To balance this out, we'll add 2 electrons to the right side. Similarly, in the reduction process, the left side has an overall charge of +2, while the right side has a charge of 0. So we'll add 2 electrons to the left side. We can see here that the number of electrons lost and gained are equal in our reactions, meaning they cancel each other out. Adding our 2 half reactions, we get our full balanced equation. Now this was a fairly simple example, but redox reaction equations can get quite complicated and difficult to balance. But following these 6 steps will allow you to balance any redox reaction equation. The first step is determine which species in your equation is being oxidized and which is being reduced. Knowing this, write a separate half reaction for each process, as we did earlier. From here, you will balance each half reaction separately. You'll begin by balancing all the elements in the equation other than oxygen and hydrogen. In our example, all elements were already balanced. You then want to balance the oxygens in your equation by adding H2O to the side that requires more oxygens. Then you want to balance the hydrogens. If the reaction is taking place in an acidic solution, balance the hydrogens by adding protons to the appropriate side. If it's basic, balance the hydrogens by adding hydroxide to the appropriate side. Now to balance the charges. Count up the charges on each side of the equation and add electrons to the more positive side. Lastly, you can add the 2 half reactions together, being sure that the electrons cancel out as well as any common terms.